Okay, so welcome back to discussion on electromagnetic waves. So today we'll be discussing about polarization of wave. Okay, we know that we can classify the wave into two category depending upon the direction of oscillation and the direction of propagation. So the wave we can classify into two. So one is called longitudinal wave, and the other one is called transverse wave. So in longitudinal wave, the oscillation, direction of oscillation and the wave propagation are along the same direction. Oscillation and direction of propagation of wave along same line. So the best example is the wave passing through a spring. So if you oscillate the one end of the spring like this, then there will be energy propagation in the forward direction. So that is so there the oscillation of the spring and the propagation of wave along the same direction. Such kind of wave is called longitudinal wave. And the thing is, in case of longitudinal wave, there is no choice for oscillation. There is no choice for direction of oscillation. Now we can look at the transverse wave. So in the case of transverse wave, the oscillation is perpendicular to direction of propagation. Okay, so we can take the same example. So consider spring. If you oscillate like this, then you will get a wave. Okay, how would be the wave? So this kind of wave you will get. Okay, so here the oscillation is vertical direction and the energy is propagating in the horizontal direction. So the oscillation of the wave and direction of propagation are mutually perpendicular. Such kind of wave is called transverse wave. Okay. Now, in the case of transverse wave, there is a choice for oscillation. Because this oscillation can be along a different direction also. It need not be along this kind of vertical direction. It can be some other direction as well. So for that, better we can assign some direction. It is X, Y, and Z direction. And we have a wave propagating towards that direction. So the oscillation can be along different directions. So either the wave can oscillate along X direction like this. Is one possibility. The string is oscillating along X direction. This is one possibility. Now the another possibility is the wave can oscillate along Y direction. Okay, so it can oscillate along X direction, or it can along Y axis, or it can oscillate along in some other direction, some inclined direction. Okay, so that means there is infinite choice available for the oscillation. But however, there are two independent direction for oscillation. The x and y are two independent direction. Okay, because any other oscillation we can resolve into two x and y oscillations. So there are two independent direction for oscillation. Okay. Now, if the oscillation is fixed along one particular direction, then we say that the wave is polarized. Okay, so suppose if the wave is propagating along this direction, okay, this direction is not towards, suppose this direction I am putting as n. So if the oscillation of the wave is fixed along n direction, the direction n cap, where n cap is a unit vector, then we can call it the wave is polarized, and the direction of the oscillation is called the polarization direction, and the corresponding plane of the wave is called the plane of polarization. Okay, so if it is confined, or if the wave is oscillating along n direction, then we can write f tilde of zt equal a tilde e raised to I kz minus omega t, and direction is along n cap. Okay, so if the direction is along x direction, then how will we write? So if it is along x direction, if the wave is polarized along x direction, then how will you write f tilde of zt? So if it is polarized along x direction, then that is this black wave. Then we can write it as a tilde e raised to I kz minus omega t x cap. So if it is polarized along y direction, then f tilde of zt is a tilde e raised to, okay, better we can use some other color. So this y direction I am putting as green color. So therefore f tilde of zt is a tilde e raised to I kz minus omega t y. Now this the direction n we can resolve into two if you want. This direction n we can resolve into an x direction and a y direction. Okay, better we can draw it in some other way here. So this is your x, this is your y. N cap unit vector. Now it can be resolved into two along x direction black color and along y direction green color. If it makes angle theta with x, then n cap I can write n or cos theta x cap plus sine theta y cap. So therefore this can be written as a tilde is a tilde cos theta e raised to I kz minus omega t x cap plus a tilde sine theta e raised to I kz minus omega t y cap. Okay, so remember this n cap is the most general representation. So this can be resolved into two polarization, the superposition of x polarization and y polarization. So this x polarization we can call it as a vertical polarization, and y polarization we can call it as a horizontal polarization. So in usually in the polarization symbol in optics, This vertical polarization will denote by symbol double arrow, and the horizontal polarization will denote by the symbol dot. So this the X basically represent as this double-sided arrow, the because it is vertical, and the horizontal polarization. Horizontal means that it is perpendicular to this plane of this screen. So that is inward and outward to the screen, and that will be denoted by symbol dot. So if both oscillation is present, then this would be the symbol, and usually will call it as an unpolarized representation. And for polarized representation, if the oscillation is confined on along one particular direction, then either we put it as mm, double-sided arrow or dot. So that is the way we are writing. But okay, now remember this n cap is again a polarized light or the polarized wave or plane polarized wave, because here the direction of oscillation is fixed along one direction, and for our convenience we have resolved that into the x polarized wave plus a y polarized wave, but still it is the polarized along one particular direction. The wave is said to be unpolarized if the direction of oscillation is random. Okay, so if the direction of oscillation is not along one particular line, and when if it is random, then we will call it as a plain unpolarized wave. Okay, otherwise it is called the polarized. Okay, so the concept we want to look at here is the term polarization. So the polarization is if the oscillation of transverse wave is fixed along one direction or along one line, then the wave is said to be polarized. The direction of oscillation of polarized wave is called the polarization vector. Polarization direction or the polarization vector. So the polarization vector in general denoted by symbol n cap. Okay, and finally the plane containing the polarization vector n and direction of propagation k is known as plane of oscillation. So certain textbook call it is the plane of polarization also, but it is slightly confusing because certain textbook says it is just plane of oscillation, and the plane perpendicular plane of oscillation is a plane of polarization. So that kind of certain difference are there, that is depending upon the different orders. Okay, so for the time being we no need to involve such problems. Okay, so we are not discussing about plane of polarization. We have just said what is plane of oscillation. So the plane which contain n and k is called plane of oscillation. Now both this n vector, the polarization vector, and the plane of the propagation vector would be perpendicular. Therefore, the dot product between the n and k would be always zero. Okay, so that's all about the polarization. So with this, we have completed the discussion of the general and the review of the waves, particularly sinusoidal wave. So we have started discussing the wave function, the differential equation for the wave. Then we have discussed the sinusoidal wave and its different properties, and finally we discussed about the polarization. Okay, so next we'll start the real topics in our electromagnetic wave module. That is basically what is an electromagnetic wave and how it would be discussed. So that we will start from the next class onwards. So see you then. Bye.